Today we're going to be looking at solving quadratic inequalities. We're going to solve it 3 different ways. The first way we're going to solve it is by using a table. So if we have the inequality x squared plus x is less than or equal to 6, like most things we've done with the quadratics, we want to set it equal to 0. So we want to make sure it's equal to 0. Now, it's going to have an inequality symbol, so you won't have that equal sign, but the concept is still the same. So this one will be x squared plus x minus 6 is less than or equal to 0. We then want to use our calculator to make a table. So again, you can use your calculator. We're going to make a table. So we know we'll have our x values, but instead of writing our y value, I'm actually going to write what y is. So y is equal to our inequality. So this is x squared plus x minus 6. So our x is the x value. Our y is really this x squared plus x minus 6. What our statement right here is telling us, what this less than or equal to 0 is saying, is we want to know when is this less than or equal to 0. So as we go through our table, we're looking for this to be less than or equal to 0, for x squared minus x minus 6, or our y value to be less than or equal to 0. So you'll type this inequality into your calculator, x squared plus x minus 6, and go to the table. You want to look where your y values are negative or equal to 0, and we're going to create a table. You want to show both sides, so don't start exactly where your answers are. Give at least one on either side. So if we look at from negative 4, 1, 0, 1 to 3. So if we look at all of these table values, and you want to actually draw out the table for me. If I ask you to solve by using a table, then we'll fill in the y values associated with this. So this one is 6, 0, negative 4, negative 6, negative 6, negative 4, 0, and 6. So we want to look where our y values, so where these are less than or equal to 0. If you notice, they are equal to 0 here at negative 3, and it's also equal to 0 at 2. And everywhere that it's less than 0, that's where our y values are negative, so all these points. So everything between negative 3 and positive 2, my y values are less than or equal to 0. So the x values are going to be our answer. However, to know which ones to choose, we're looking at the y values. So we want to know, when is this less than or equal to 0? Well, it's less than or equal to 0 from negative 3 to positive 2. So our answer is going to be negative 3 is less than or equal to, because we included, we have an equal to in our original problem, x, which is less than or equal to 2. So that means anytime x is between negative 3 and 2, that is a solution to this inequality, because that's when my y value is less than or equal to 0. Next, we're going to look at solving by graphing. So we're going to look at the inequality y is less than x squared plus 3x minus 4. So if we look at this inequality, we need to graph it, and in order to do that, we need to know where it crosses the x-axis. Like we said before, we want everything to be set equal to 0. So the first thing I'm going to do is actually change this y to a 0, so we have x squared plus 3x minus 4. We want to know where our x-intercepts are, so we can do that by looking at the graph on your calculator. You can look at the table in your calculator, or you can factor. Sometimes you may end up having to just swing and divide, or use your second trace and find the zeros if one of your roots is at a fraction, so just keep that in mind as you go, or at a decimal. So if we factor this, we're looking for what multiplies to be negative 4 that adds to be positive 3, which would be positive 4 times negative 1 gives us negative 4, and they add together to be positive 3. I'm also going to change where I put my 0. Right now this is saying is 0 is less than my graph, or 0 is less than y, 0 is less than all of those values, which doesn't make as much sense as saying we want to look where my graph is greater than 0. So I'm switching it around just that way it makes more sense to us. So we're not saying 0 is less than something, we're saying something is greater than 0. They mean the same thing. It's still opening towards my equation. It just makes more sense mentally as we think through it. So when we look at this, my roots are going to be at negative 4 and positive 1, because when we solve our factors, we set them equal to 0. So we'd have one at negative 1 positive 1 and negative 4. Because this is a less than and not an equal to, I'm going to put an open circle, so that way when we go and we write our answer, we know what we're looking for. We know to not put an equal to sign. We also need to think about what my graph looks like. Here, this is a positive x squared, so we know my graph is going to open up. I'm not overly concerned with where those points are, just mainly which direction it opens. So we're going to just sketch in our graph. Knowing these critical points, we can just sketch the graph from there. So what this is saying where is my graph? So this is saying where is my graph greater than 0. So when we look to where it's greater than 0, that's when my y value was positive, which is also when it's above the x-axis. So these are all different ways of thinking about where we're looking. So since it's greater than, we're looking for where it's above the x-axis. So if we look at my graph, we want to see, is my graph above the x-axis between these 2 points or outside of these 2 points? If you notice, between the 2 points, my graph is below the x-axis. So if we think about outside of these 2 points, my graph is above. So outside these points, if I go to the right, my graph is above. If I go to the left, my graph is above. So my solutions are going to be less than negative 4 and greater than 1 because it's outside. So because there's this gap, we're going to have an or. So we're going to say x is less than negative 4, but not including it. So x is less than 4, anything smaller than negative 4, or x is greater than 1. So my solution there would be x is less than negative 4 or x is greater than 1. Because we have that gap in there, that's why we need to have the or. The last way we're going to look at doing this is algebraically. Okay, so algebraically, if we were to have the inequality x squared minus 2x is greater than 15. In order to work on this, we want to set it equal to 0 because we want to look at factoring so we can find our critical values. Our critical values are like our x-intercepts, our roots are 0. Those are called critical values. They change the dynamics of our parabola. So we are going to have x squared minus 2x minus 15 is greater than 0. Here we're going to factor. So on all these algebraic ones, we're going to be factoring. You might have to swing and divide if there's a number in front of the x squared. So what multiplies to be negative 15, that adds to be negative 2, would be negative 5 and positive 3. So this is when x is equal to 5 and x is equal to negative 3. We know the solutions to this are when x is equal to x is equal to positive 5 and x is equal to negative 3. On the algebraic ones, we're going to be making a number line. So we know negative 3 is on my number line. We also know that 5 is on my number line. We know that this is a greater than. It's not an equal to, it's just a greater than. So we're going to be having open circles on both of these. So they'll both have open circles. In order to decide which x values are true in this situation, we need to do a few test points. So we're going to test some points to the left, in the middle, and to the right. So if we test a point to the left, like negative 4. So I'm going to test negative 4. We're going to go back up to my original equation. So if you go, or my original inequality. If we go up to my original inequality, we'll have negative 4, remembering to always put it in parentheses, squared, minus 2 times negative 4. We want to know, is that greater than 15? Negative 4 squared is 16. Negative 2 times negative 4 is positive 8. So plus 8, is that greater than 15? We get 24 is greater than 15. So this is true. Because that's a yes, we're going to shade to the left of this line. Now we're going to test a point in the middle. So if we test 0. So we'll have 0 squared minus 2 times 0 is greater than 15. 0 squared is 0. Minus 2 times 0 is 0. So is 0 greater than 15? No, it is not. So we will not be shading the middle. Then we're going to test to the right side. So we will test the point 6. So we'll test 6. So 6 squared minus 2 times 6 to see if that is greater than 15. We have 36 minus 12. That gives us 24 is greater than 15. This is true, so we're going to shade out here. Whatever we've shaded here in purple, those are our solutions. So our solutions here are when x is less than -3, because we shaded to the left, everything's smaller than, or, and again, a not equal to, because our original problem did not have an equal to, or when x is greater than 5. That would be our solution, because that is when my y values satisfy the situation. That is when x squared minus 2x minus 15 is greater than 0. So those are the 3 different ways you're going to be doing these. As we do your assignments, I'm going to specify which ways to do it, and then you'll have an opportunity to choose which method you would like to use.